Hello.
Yeah. Thanks, Ted. Hope everyone's had a cup of coffee, and I hope I've got some content to keep you awake. This works? Yeah, cool. So just to add to that introduction, that's me on Twitter. I'm Director of Technology with Expedia. I serve 6 engineering teams who are spread across 3 different cities around the world. So distributed teams is definitely a huge part of my existence. Our mission is to enable you to find that perfect flight and have that perfect seamless experience when you go to book that flight. I have been on this journey with Expedia for 2.5 years. And we're about 4 years, or a better part of 4 years, into our journey of retiring our Monolith. And we're about 6 months away from being able to do that. So this is a culmination of lessons picked up by the team and by myself while walking that journey. No introduction is complete. Thanks for starting the cricket note today. No introduction is complete for me without talking about cricket. The summer is here. Hopefully there won't be any sandpaper, and hopefully we'll have a good fight. So what's not in this talk? There's 7.8 million search results for the word microservices. So I'm not going to define that term for you. None other than James Lewis and Martin Fowler. They're the authority for me. They wrote this post back in 2014, I think it was. If you haven't read it, I highly recommend it. So how do you break down your monolith and move to a microservices architecture? I believe there isn't a one-size-fits-all recipe that's going to get you there. So I'm not going to talk about that. What I will do is to share some lessons that we have learned as we walk that journey. So a little bit of context. This book came out last year, I think, titled Production Ready Microservices, written by Susan J. Fowler. Let me quote her quickly. One of the biggest challenges for organizations that have adopted microservice architectures is the lack of architectural, operational, and organizational standardization. Hold on to that. It's a bit of a recurrent theme to my talk. Scale presents its own challenges. That was me at the Grand Canyon a couple of years ago. And I remember thinking to myself, man, that will be one hell of an effort crossing the canyon from one end to the other. At Expedia, everything we do is about scale. There's 250 people. There's 250 people who work on the flights product and technology team. There's 150 million search requests per day, growing organically year on year. 50 plus microservices on our platform, spread across 5 different cities: Seattle, Chicago, Kochi, New Delhi, and Sydney. And it's here at this scale that I've been migrating from this. Now, many software applications today can be broken into these distinct elements: a front end, a back end, a database, maybe some third parties. A request start at the front end because the user did something or wants something. They go to the back end does a bunch of business logic, goes to a database, goes to some third parties, returns an answer. Now, our flights platform definitely fit into this shape about 4 years ago. And I guess, in principle, it still does today. We all know how this story evolves, right? Features pile up, tech debt builds up. As your company grows, as your application grows, a lot of people leave through attrition. Domain knowledge, industry knowledge leaves the building. Features get harder and harder to implement. The result is a slow grind. So you make this decision, right? Hey, we're going to do this. When we looked at that and we said, well, we have a shopping backend and a booking backend. And we actually even did that. We deployed it on multiple servers. We have a shopping farm and a booking farm. But we realized very quickly, hey, that's just a couple of mini monoliths. We haven't actually helped the situation. So we then went a step further and we said, hey, what does our shopping platform look like? What is that engine that's going to really help us scale into the future? So that's a peek of what that looks like. I won't go into too much detail. Suffice to say, there's probably multiple code bases under each of those boxes. And as we broke out of our monolith into many services, we quickly learned that monitoring, alerting, performance testing, functional testing, tech debt management, security, compliance, deployment, it all became harder. It's not easy. Our organization structures had to evolve to keep pace with that architecture. Will it scale has become an integral part of the definition of done that our teams employ. A lesson we have learned a few times by launching features or changes in production only to realize that a component somewhere in our platform wasn't ready for that extra traffic. Ouch. What do you think of when you see that image? Anyone? Exactly. Stability and reliability, right? Am I going to be able to cross that bridge? Yeah. Is one of those side pylons going to fall off? Is one of the slats going to fall off? When I looked at that image, I thought, microservices architectures are kind of domino effects waiting to happen. So how do we guarantee stability and reliability? Most of what I'm about to say is probably common sense, and you're probably thinking, why am I saying it? The thing that I'd like you to hold on to is that a lot of this is easy when it's one code base or a handful of code bases. But how do you do this when you have 50 plus code bases? Or 50 plus services, but 200 plus code bases with 250 people across 5 different geographies? So writing unit tests, functional tests, integration tests, we all know that they're good development practices. But are you running them at the right time, at the most impactful moment? Depending on the nature of your application, you probably want to run them, all of them, as part of your pull request process. You probably want at least 2 reviewers looking at the code before it is merged to master. Sorry, Adam. Invest in tools like Sonar Cube, right? Take away those debates around where that semicolon goes. Let humans focus on what is the intent of this change. Let them not be null pointer detectors. So talked about automated testing. I want to talk about specifically one type of automated tests, and they're API boundary tests. Something that I picked up after I started at Expedia. It's basically integration testing, but integration testing in a deployed environment. We use this approach where we use Cucumber to write all our scenarios. We use Scala test to execute those API requests and to validate the responses from a client's perspective. And it's really imperative that the developers writing these tests treat the service that they're testing as a black box, right? Remove that bias from your tests. The validations can then be against the schema of that particular message, or they can be from the business perspective. So let me give you an example. Let's say you're testing this, the shopping path that I showed you before, or the shopping architecture, and you write a scenario for testing a one-way search request from Sydney to Melbourne. You want to make sure that you only got one-way flights back, that return flights didn't sneak in there, right? You want to make sure that they all cost more than $0. You probably want to make sure that, if there are some business rules at play that says, hey, we want to have Virgin Atlantic or Virgin Australia favored over Jetstar for this route, then you want to make sure that favoritism exists in the return data set. These are all possible, and this battery of tests helps us guarantee that experience with every commit to master. All of these are real examples, by the way, of bugs that we've created. Automation of this variety is very empowering. And I want to talk about one other type of automation, that's infrastructure as code. So like most others, I started playing with AWS when it first came out. And it was really a freeing experience, not having to rely I love people, but not having to rely on other people to stand up infrastructure. I could just do it, right? I could go to the console, I can spin up a server, deploy my code, and boom, off you go. That was great. At a startup that I won't name, we even signed a contract with AWS that said, hey, we will guarantee you that we'll use so many instances of this type for the next 18 months. And we got amazing discounts. That was awesome. But little did I realize that we were just creating data centers in AWS because we didn't treat that infrastructure as code. At Expedia, what we do is that the required infrastructure for any service is captured as code with the code base, right? It's taking that 12-factor philosophy that Heroku pioneered and really putting it into practice. So the service knows how to install itself, what it needs in any given environment, whether that's your lab or your production environment. And this really helps us with a couple of little things, right? One is, with every commit to master, we tear down and rebuild the infrastructure from the load balancer down to all the nodes. It helps us because we can very quickly roll out all the patches, all the operating system changes, all the other dependencies that an application relies on. The other advantage that it gives us is then it moves the risk away from your production environment and brings it to your laboratory, right? If you change a patch and it's going to break something in your service, you find out because now you've deployed that patch in the lab first before you roll it out into production. So I would stress that this is as important as any testing you do. So that brings me to the pipeline. I won't go into too much detail. There's a lot of information there. But I do want to ask, it's easy to say automate everything. But I think it's really important that we're clear on the purpose. Why are we automating everything? Most might say that the purpose is to automate the build process to get the build ready for production. Well, this is true. I look at it slightly differently. Every step in that pipeline is designed to break your build, right? It's designed to prove why your change is not ready for production. And if you get through that to that tagged step at the bottom, press the button, get on with it. What are we waiting for? It's Friday, 5 p.m. It's a public holiday. Doesn't matter. If you're ready, go, right? It's really bringing that empowerment by using that philosophy and creating the tools that reinforce it. So I mentioned Sonar Cube before. So that's a screenshot from one of our services. It shows you top-level code health, insight, and trend. And then the other one that Sonar Cube gives you is high code complexity. So these are files from one of our services that have high code complexity. And then we have metrics-driven conversations in our sprint planning that says, well, that booking details view context, we're not okay with that. We need to drive that down. We need some time to work on it. And the team can get together and have those discussions and drive those stats down. They're empowered to make that happen, and they have the tools available to them. It's not an opinionated discussion. It's about those numbers. So let's talk about scaling and performance. Does anyone recognize that photo? Yeah, it's the Tesla battery farm in Adelaide, or in South Australia. And when I remember I was looking for an image for that topic, and I was like, that's scaling and performance. So for us, right, firstly, it's about how we divide the functionality into independent features or tasks, right? Do you design your services so that any dependency between two services is captured over the API? There's no random database links. There's no random reaching behind the door and doing something. It's all through the API. Do you build resiliency in those calls, right? Just the way you do when you call one function from another within a class. You need to apply those same principles when you're interacting between services over HTTP. A lack of this type of resiliency has bitten us pretty badly in the past. When a change in one part of our platform resulted in booking failures, because the booking architecture decided that one particular field was mandatory and it was missing because of a defect, and customers were left hanging at the door. Secondly, it's about how services scale in response to the incoming traffic. I don't know about everybody else, but traffic is something that is always going that way for us. Yes, Cyber Monday, we had this thing where our marketing team decided, hey, we're going to issue a new flights coupon every hour to run discounts. That was great. Thankfully, everything scaled. But we had unprecedented volumes of bookings processed within 24 hours. It was our busiest day. And thankfully, it was all in AWS and it could scale. So when we talk about scale and traffic pattern, right, I'm talking about requests per second. Are your services set up to deal with that traffic? Will they scale? Have you looked at, is your service CPU bound, or network bound, or memory bound? So performance then, talking about latency and utilization, performance is about proper task handling, timely responses to your clients, and effective utilization of your infrastructure, right? If you don't need a C5, don't deploy a C5. Deploy the thing that you need, right? If you're okay, if your service is going to behave well with 75% CPU utilization, do that. If you never get burst traffic and you're okay with 75% CPU utilization, do that, right? But if you know that you do get bursts because you get crawled by meta search engines, then build for that scale. So you really have to understand that traffic pattern, understand the latency that is okay for your service, and then decide what kind of utilization behavior you're going to implement. If service A calls service B calls service C, and service C is degraded, it's likely causing a cascading effect. Understanding that bigger picture is important, and building guardrails for that in production is important. Recently, we spent a lot of time investing in Hystrix, where we injected Hystrix into each of our services across our platform so that whenever a component is degraded, it could automatically get isolated really, really quickly. And engineers can respond to that and figure out why and restore health. So all of this brings you to capacity planning and automation. So, capacity planning is this exercise that we do all the time, which basically says, hey, right now we get X 10,000 requests a day or X 100,000 requests a day of this nature. Based on my performance tests, they tell me that I need, on average, 10 of these instances running on a daily basis. So I project that at 10% traffic growth, which is what the business is telling me, I'll be spending so many dollars a month for the next 12 months, right? Really important muscle. And every team does this. It's not done at an executive level. It's not done at my level. It's each team led by their engineering manager or their senior engineer looking at their service, understanding the cost, and talking about that cost, and understanding how to optimize that cost. So we built some tools for them. Amazon has this thing called the Trusted Advisor. So we wrapped our own service around it. It sends an email every day. Hey, service X, your instance type is M4. You're underutilized. You're only using 3% of your CPU, and you could be saving $300 a day. It is reactive, but it's better than nothing, right? Knowing how much you're spending is really empowering. The cultural change we saw after we released this within 3 months, we regularly heard teams are requiring and demanding bandwidth so that they could address this. They didn't want to show up in this report. Right? It was a big shift for us. Monitoring and observability. When you go from a monolith to a microservice, your fault domain just multiplies, right? If now, instead of you being in process, you're between processes. there is a network, there is a firewall, there is multiple components that could fail. So logs, metrics, and traces are super, super important. Think about this for a minute. Many an outage is caused by bad deployment. When you have a single monolith, identifying where something has gone wrong is probably fairly easy. Identifying that across 50 services in your production environment is definitely more difficult. So you need to understand what your key metrics are. What are your trends, right? How does your service behave, right? We focus on CPU, RAM, threads, DB connections, garbage collection. All of this is on dashboards. All of these have trends that we can trace back 30 days at a minimum. At an application level, we look at latency of your response times, downstream latency from your dependencies, API request and response rates, right? To be able to understand your traffic pattern. Is it like a sine wave? Is it bursty? Errors, which errors are spiking? Not just the fact that there is a failure, but it's actually a count of a specific error code that has spiked, so that we can figure out, oh, there is a CC decline spike during bookings. Let's get on the call to Amadeus and go, hey, what's going on, guys? Do you have a payment gateway issue? Should we shift traffic away from you while you recover, right? We need to be able to respond really quickly so that customers are not left hanging when you're trying to book that flight. Clean and consistent dashboards, right? With 50 plus microservices, we quickly realized that it was getting really, really hard to diagnose the problem, because everybody had their own idea about what a good dashboard looks like, right? Every engineer likes to do it their own way. All great. But when it comes to production support, and when you're trying to empower 250 people to support their own services, I was going to use a different word, you need to think about what your dashboards look like. What information do they convey? What questions are people trying to ask when they come to a dashboard? So we spent a bunch of time. We piloted a template. We came up with a design. We rolled it out across all our services. And in over 3 months, we reduced our mean time to detect by 15%. We've learned some lessons along the way. Now we're doing version 2 of that template because some things work, some things don't. But along the way, we kind of standardize on some things, right? All dashboards should look this way. Everybody should be sending their time series metrics to Graphite or to StatsD, so that Graphite can be used to dashboard everything. All event logs should go to Splunk. They should all be sanitized using this library so that we don't accidentally reveal random things that we shouldn't. Things like that. Most importantly, with event logs, I find is that your keys that you log, they need to be consistent. Tools like Splunk are case sensitive. So if one service says user ID with a capital U and another service says user ID with all lowercase, or maybe sticks an underscore between user and ID, all of a sudden you can't stitch them together. You can't trace the journey of that request through your platform. Which brought us to distributed tracing. We realized that it doesn't matter how good your event logs are. It doesn't matter how awesome your Graphite metrics are. We need to be able to see the journey that a request takes through our platform. So don't get me wrong, per process logging and metrics are super important, but neither can reconstruct that elaborate journey that 50 plus microservices represents. So really quickly, I talked about dashboards. I don't know how legible this is at the back of the room, sorry. But this is a dashboard represents our template, but this is a specific service. It's our ticketing, from our ticketing platform. When I look at this, right, overall I can see everything's healthy. I can see CPU is about 45%. It's within trend. There's a trend line in there in the gauge. I can see memory is about 59, and again, for this time of day, it's in trend. You can see it's kind of like a sine wave. I can see there's 100 tickets waiting to be ticketed. It looks all about normal to me. Nothing is spiky. So when I'm quickly scanning through dashboards, or we have big screens in all our offices where our engineers sit with these dashboards just cycling through all the time. So when people walk past it or they're doing their stand-up and they notice something, they can very quickly get alerted to what's going on. So distributed tracing. About 2 years ago, we started using and playing with Zipkin. Thank you. And Zipkin's a product that Twitter built, open sourced it. Not sure if everyone's familiar with that. But we realized very quickly that we needed something a little bit different, a little bit more elaborate. So we built our own open tracing compliant service. We call it Haystack, and it's open source. You can look it up on GitHub. And it's based on Google's Dapper paper. So some of you may have heard of that. And basically, the idea is that every service, when it receives a request and sends a response, it sends off a trace, right? It's like creating a tracer bullet through a complicated maze, right? So every service integrates with Haystack, sends off a trace. Hey, I got this request and I sent this response. And in basically that action, you record all kinds of things. You record all the relevant metadata for that request and response. You record whether that was successful, whether was that operation successful. So that Haystack can then do this really cool thing where the red bars are where something went wrong. The blue, or what you see as black bars, are where everything was happy. It also gives you response times. Hey, that message in Mormont, it took 1,505 milliseconds. Whereas the one below, it took 605 milliseconds. So you can see exactly where latency might be spiking for any given transaction. All right? A transaction is basically for us, let's say you're trying to search for a flight. Right? As soon as that search request arrives into our shopping platform, that's a transaction. And we can trace that all the way from when you clicked on that search button to where it went outside our network to our providers so that we can get you real-time content to show you that content. By doing that, we also get real-time TP99, TP55, and the mean for your response times, as well as success failure percentages and the trends. Really useful when you're trying to trace through a huge platform. Lastly, this is not very clear. It's a real-time service graph, basically. So you have real-time documentation of what your architecture looks like, how messages flow between your components. You don't need to maintain static artifacts. The system does it for you. So really quickly, I know I don't have a lot of time. So team structure is really important. If you're about to write stuff in JavaScript and you've never deployed a line of JavaScript to production, you probably want to address the shortage of skills on your team. Going down a microservices route does enable your teams to be more cross-functional because you're driving ownership to each team. I was going to talk a little bit about that, but we'll skip that for a minute now. Time frame. It's really important to think about how long a team sticks together and works on a code base. The longer they do that, the more performant, scalable that service is going to be, the stronger your code base is going to be. And there's Conway's law, which was mentioned earlier, and I'll bring that up again as well. We've had instances where team on one side of the world has released a feature and taken a whole subsection of traffic down because something didn't scale and nobody had thought to ask the people who own the service, hey, will it scale? So Conway's law is super important, right? Got to build communication structures in your organization that support your architecture. Remember, it's a journey. It's not a destination. Thank you.